Hi friends, welcome to Unit 5, Day 5 notes. This one's about proving triangles similar using side, 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 and side angle side similarity. Before we jump in, let's talk about just the similarity theorems and postulates so far. So far we've just had AA or angle similarity. So now we're adding a few more into the similarity theorems and postulates list that we can use. If the corresponding side lengths of two triangles are proportional, then the two triangles are similar. Let me rotate my camera. There we go. The two triangles are similar. So here we have, if I have this side length and this side length being proportional, so I'm going to write that. If I go, let's go alphabetical order. I was thinking about this for a second and I was like, it's easier. So I'm going to do this purple here from A to B and then purple here from R to S. So if I do A to B, so if the proportion of A to B over R to S is equal to the proportion from B to C, with this light green here, and then S to T. Now it's kind of hard to see. You can kind of see it. B to C, and then over S to T has to also be equivalent to C to A and T to R. Then what we have is triangle ABC is similar to triangle RST. So if those proportions, so if we have proportions of the same across all the side lengths, then we know that the two triangles are similar. So for this one, what it's looking for is it wants to know, is triangle LMN or RST similar to triangle ABC? So we actually have, so we're not checking if these two are similar to one another. We're checking to see if this one's similar to this one or this one is similar to this one. So to set it up, what we're going to do is we're checking being consistent. So what I'm going to do is I'm going to color the inside of this first one with my red. So you can kind of see, like, this is the one that we're going to check. We have to be consistent. Essentially, with that entire triangle, you want it to either be in the numerator for all of them, or you need to be in the denominator for all of them. You don't want to switch. If you switch, then you get messed up. And then I'll do light green for triangle LMN, and then purple for RST. Okay. So starting off, we're going to check to see, so let's do BC, length of BC over length of MN equal to, I should have this fraction bar. There we go. Get it all set up with my colors. There we go. All right, got that part set up. All right, so then MN is there. Kind of hard to see. I think I'm going to switch to a darker green. I feel like you may not be able to see it. Hopefully that one's better. It's a darker color green. Yeah, that's a lot better. Okay, and then let's do NL. I'm going rogue. Going different than what the teacher copy of the notes has. I don't think I like the way that that's in there. And then LM, so I just need to be consistent with my other triangle here as well. So I have BC, and then I went to NL, so I'm going to go to C to A, and then A to B. It's a little bit weird. Put AB last. I usually put AB first. All right. So now we're just checking to see if these proportions are all the same. And we don't know if they are, so we're checking to see if they are. So that's why we put question marks over them, because we don't know if they are proportional or not. So let's see, B to C, so that's going to be 12. C to A is 10, and then A to B is 10. So again, I'm checking to see if these are proportional. And then the green, let's see, M to N is 8, 6, and 8. So these can reduce, so I need to see if they reduce all to the same values. So looks like, let's see, 4 goes into both of those. That gives me, let's see, so that would be 3/2 for the first one is equal to 2 goes in both of those. What is that? 5/3. Again, question marks because we don't know if this is true or not. 2 goes into both of those, and that's 5/4. So these aren't. So I know that triangle ABC and triangle LMN, those can't be similar. So now, hoping then that this triangle is similar to the other one. So let's see if it is. Again, setting it up. This time I'm going to use purple now instead. Now again, it doesn't matter as long as I'm consistent across the numerator and denominator. So I'm just going to get it set up here with my proportions using black, and then I'm going to fill in. So again, with the red, it doesn't matter where you start. I'm going to be consistent since I started with BC with the other one. I'm going to keep BC here. So that means CA and then AB. And then I have to follow that same procedure here for the other triangle as well. So that's going to be ST, TR, and then RS. So then the values, again, those values are going to be, let's see, B to C is 12. It's going to be the same, 10 and 10. Oops, missed my fraction bar. There we go. And then ST is 6, TR is 5, RS is 5. So now, when I reduce these, hopefully they reduce down. 6 goes into both of those, that's 2/1. Equals 5 goes into both of those, that's also 2/1. 5 goes into both of those, that's also 2/1. And this is. So that means that triangle ABC is similar to triangle RST. And this is by the side similarity. So that one's set. Perfect. So that's how you do these. Notice that I'm using different colors. That's really helpful as you're going through this. It's helpful to use different colors so that you can just kind of see the differences between them. So I'm going to do the same here for this one as well. So same color scheme where I'm doing red for this one, dark green for the middle, and then purple here for that one. So I'm going to set it up just like we did with the other one. So I'm going to have here, and then there we go. Here, equal sign with a question mark. And so now I've got, I'm going to go in alphabetical order this time. So I have AB, BC, and then CA. And then now if I do green, again, I need to make sure my order follows. So from A to B, it's looking at L to M. So I'm actually not even looking at the picture. And if you look at the picture, sometimes you get messed up. M to N, and then N to L. There we go. So now, checking these. So again, making my fraction bar, my equal signs, getting everything set up. So the length from A to B is 8. The length from B to C is 10. The length from C to A is 9. And then L to M is 4. Make sure you read the diagram correctly. L to M is 4. M to N is 5. And then N to L is 4.5. And then now I just check, see if these reduce. They all, 4 goes into both of these. So this is 2/1. That's also 2/1. And then this one is also 2/1. So it actually does work. These are all congruent. So that means that triangle ABC is similar to triangle LMN by side. Now, It could also be similar to this one, so I need to check that as well. So setting this one up. So fraction bar equals question mark, fraction bar equals question mark, fraction bar. So A to B, B to C, C to A, and then for my other triangle, that would be R to S, S to T, and T to R. And I'm just going to check to C. So A to B is still 8, still 10 for B to C, and then C to A is still 9, and then R to S is 6, S to T is 12, and then T to R is 9. Okay, so immediately I see that this isn't going to work. 9 over 9 reduces to 1, and then both of these reduce to be over greater than 1. I didn't even switch colors for my pen. So I know that this isn't going to work. Just, I can see it right now. I can see in my, simplification, it doesn't work. So at that point, you're good. You don't need to continue working through it. As soon as you see it's not working, it can't work. So you just note that. I put a big X, put X's there, knowing that those reduce to 1. Let's see, this one reduces to 5/6. So does not equal 1, and then 4/3. So no, those definitely don't equal one another. They're not proportional, so it can't be similar by side-side similarity. All right. During the next video, as we jump now to the side angle side theorem, I will see you there. Bye, friends.